This is for Kia Cerato in 2012, and it's a three-pin wired engine cooler temperature sensor. I'll be using ECT. So in this, based on the wire diagram that we have here, here's the circuit of the engine coolant temperature sensor, and in it we have the first pin. Okay, before I go ahead, on this very sensor, Kia starts their numbering of connector. If it is male, it will start from left to right. If it is female, it will be right to left. So in this case, our number one is starting, since it's a male connector, our number one starts from the left, which is 1, 2, and 3. And on the diagram here, we have 1, 2, and 3. So checking the first one, which is number 1, is the ground. The number 2 goes to the instrument cluster and the AC control module, while the third one actually goes to the brain bus, or it is the ECM as a signal line. So which means, interpreting that here, this is number 1, which is to the from the brain bus ground. This is number 1 brain bus ground. Number 2 is to the instrument cluster. Number 2, which is to the instrument cluster, and then number 3, which is the signal from the brain bus. So for us to test this sensor to confirm if it is actually working or not, it's a negative temperature coefficient kind of sensor. That is, as the temperature increases, the resistance reduces. So, and which means the ohm readings will eventually reduce as the temperature increases. Well, I don't think I'll have the I just wanted to show us how to check if the sensor is good or not. And underground, how to know if the sensor is good or not, you would need to test the signal line and the supply line to the instrument cluster by connecting your multimeter in resistance in ohms, and one leg will go to the ground while you test the resistance for both the signal line and the instrument signal line as well. So on this ground now, what I'm going to do, I have my multimeter set to ohms. This is mega ohms. I will have to put my first pin into the what's the name? So now I have connected my ground line to my multimeter, and the number 2, which is the line that goes to the instrument cluster, I'm putting my probe, maybe next time I'm doing this, into that, so I avoid touching the signal line, to avoid if there's going to be any failure. So now what my multimeter is telling me it's overload, which means the sensor is really bad. Let me try and wiggle it and see. Okay, maybe there's a partial contact from the sensor, though I'm making sure that my hand is not touching the metallic part, so that it does not give me any false reading. If I should touch that, I think there should be, yeah. So in this sensor now, as you can see, I'm wiggling this like so it means the sensor is actually having a partial contact. There is a short circuit somewhere along the line from the brain bus to the instrument cluster. So in this very situation, the sensor will be giving a false reading, obviously, on this line. So for me to have confirmed that, I will need to check the signal line too. and then so I'm coming. Okay, all right, so now you can see the signal line has been connected. So this confirms to us that it has got some resistance. So this is how the resistance for the instrument cluster information should have come, but unfortunately the sensor itself is bad. So if for instance we have a good engine coolant temperature sensor, you would have gotten similar reading, maybe not the same reading, but a reading closer to this, and that would help us to know that the sensor is good. And as for instance, I have a hot water here now. I put this sensor in it. Automatically, these very readings now will start going down because it is an NTC kind of sensor. So as the temperature goes high, the resistance drops. So here with me right now, I have a bad engine coolant temperature sensor, and this is how best to easily test this system. So that is that for today. Thank you.